Something just happened in deep space that left scientists stunned, and it came straight from the James Webb Space Telescope. For years, physicists have operated under a well-established set of rules: the Big Bang, the timeline of galaxy formation, the speed of expansion. But now, Webb is throwing all of that into question, one discovery after another. This telescope is turning the universe into a mystery novel, with every new chapter wilder than the last. We're talking about galaxies that formed too early, structures that shouldn't even exist yet, and evidence that might suggest we've misunderstood the very shape of the cosmos. This isn't science fiction. It's happening right now, and it could rewrite everything we thought we knew about space and time. And it all started with galaxies so far away. It's forcing scientists to rethink how the universe was even born. When the James Webb Space Telescope first opened its golden eyes to the cosmos, scientists expected beauty. What they didn't expect was a cosmic mutiny. Within weeks, Webb detected a galaxy so ancient, so bright, and so massive, it practically screamed impossible. Known as Mom, Z14, this galaxy existed just 280 million years after the Big Bang, a time when, according to every model we've trusted for decades, the universe was still dark, chaotic, and unstructured. Stars were barely beginning to form. Galaxies? They weren't supposed to exist yet. At least not like this. But Mom, Z14 wasn't alone. Webb kept spotting others, bright, red-shifted blobs that shouldn't be there. Some were 10 times more massive than the Milky Way, fully formed, with complex structures and billions of stars. It was as if someone skipped a few pages in the universe's instruction manual. At first, scientists thought it had to be a trick. Maybe the galaxies weren't that far away. Maybe their light was being magnified by gravitational lensing. Others blamed technical glitches or misinterpretations. But the data kept piling up. It wasn't a glitch. It wasn't a mistake. These galaxies were real, and they were too old to be that young. One researcher called it a slap in the face to everything we thought we understood. Because if galaxies like these formed just a few 100 million years after the Big Bang, then the timeline of cosmic evolution might be completely broken. It would mean our models for galaxy formation, star birth, and even dark matter behavior are flawed, or worse, completely wrong. And this wasn't just about one or two rogue galaxies. Webb found dozens of them. Galaxies crowding the early universe like streetlights in a city that shouldn't even be built yet. What's more shocking is how massive and complex they are. Galaxies were supposed to start small and chaotic, slowly merging and maturing over billions of years. But what Webb saw looked like fast-track giants, galaxies that somehow skipped the awkward teenage years of cosmic development. It's forcing physicists to question everything. Did stars form earlier than we thought? Was the universe expanding faster than we measured? Or is there some exotic, unknown force at play, one we haven't even imagined? And just when it seemed like these early galaxies were the biggest mystery Webb would unveil, it zoomed in on a swirling, structured formation so perfect. It looked like a cosmic doppelganger of our own Milky Way, only 13 billion years too early. Everyone expected chaos in the early universe. Clumps of gas, baby galaxies still forming, and barely any structure. But Webb found something else: elegance, precision, spiral arms. One of the most jaw-dropping discoveries came in the form of a galaxy nicknamed Julong, Chinese for candle dragon. This wasn't just another bright blob in the sky. Julong was a grand design spiral galaxy, like our Milky Way, but seen as it existed over 12 billion years ago. That's just 1.5 billion years after the Big Bang. The problem? Spiral galaxies weren't supposed to exist that early. In fact, their delicate shapes require billions of years of steady rotation, star formation, and gravitational interactions to form those perfect arms. Seeing a fully formed spiral from so early in cosmic history is like finding a smartphone in a medieval ruin. Something doesn't add up. But it wasn't just Julong. Another massive spiral, called the Big Wheel Galaxy, also showed up, lurking in that same chaotic window of time, just 2 billion years after the universe began. It was enormous, organized, and too advanced for its age. And it raised a chilling question: how many of these are out there that we haven't even seen yet? These spirals are more than just pretty. They're evidence that our timeline of how galaxies evolved might be fundamentally broken. If these perfectly organized structures could already exist when the universe was still in its infancy, what does that say about the forces shaping them? Could dark matter be behaving differently than we thought? Did the early universe go through an unknown phase that jump-started galaxy formation? Or is something far deeper hiding in the way gravity works at the largest scales? The more we zoom in, the more it feels like Webb isn't just photographing the past. It's exposing a lie we believed for decades. And the next discovery would challenge one of the most untouchable ideas in modern physics: the mysterious, invisible force we call dark matter. For decades, dark matter has been the invisible backbone of the universe. We can't see it. We can't touch it. But without it, nothing adds up. Galaxies would fly apart, cosmic structures wouldn't hold, and gravity alone couldn't explain what we observe. It's been treated as gospel in modern cosmology until the James Webb Space Telescope started digging deeper. One of the most revealing snapshots came from Webb's look at the Bullet Cluster, a pair of colliding galaxy clusters over 3.7 billion light-years away. This cosmic wreckage is famous for exposing the presence of dark matter. Two distinct clusters of mass moving through each other like ghosts, their gravitational fingerprints offset from the hot gas they left behind. But Webb's imaging went further than ever before. Its precision, especially when combined with X-ray and gravitational lensing data, offered the clearest map yet of how dark matter behaves during these violent collisions. What scientists found was unsettling. The dark matter didn't always behave predictably. Some of mass seemed to be drifting or lagging behind, acting almost like it had properties, maybe even friction, which it was never supposed to have. That's not just a minor glitch. If dark matter can interact or slow down, it changes everything. It means the entire framework we've used to explain the universe, how galaxies form, how they stay together, and how the cosmic web is structured, could be flawed at its core. Webb didn't just expose weird behavior in one cluster. It hinted that these discrepancies might be happening everywhere, at every scale. And if that's true, we may be chasing a ghost that behaves very differently than we thought. And just when physicists thought they could patch things up, Webb turned its lens toward a crisis that's been bubbling for years: how fast the universe is actually expanding. For years, the scientific world has been caught in a quiet civil war, one centered around a deceptively simple question: how fast is the universe expanding? Two major methods have been used to measure this. The first involves looking at the cosmic microwave background, the afterglow of the Big Bang. The second uses supernovae and nearby galaxies to track how fast objects are moving away from us today. The problem? The numbers don't match. The early universe measurements say the expansion rate, known as the Hubble constant, is slower. The more recent data says it's faster. Both methods are solid. Both are tested, but they completely disagree. Some researchers called it the Hubble tension, an annoying but solvable riddle. Others believed it hinted at new physics, that the universe might be hiding a secret in plain sight. And that's where the James Webb Telescope came in. Webb's precision allowed scientists to recalculate distances and refine measurements like never before. And depending on who you ask, Webb either solved the crisis or made it worse. In one recent study, Webb's data seemed to support the cosmic microwave background results, suggesting the early universe estimate is correct after all. That would mean the local measurements, using supernovae, must be flawed somehow. But in another analysis, Webb confirmed the exact opposite. The nearby universe really is expanding faster than expected, which means either our understanding of time, gravity, or space itself is off, or something strange is going on in the dark energy that drives cosmic expansion. So now, instead of resolving the tension, Webb may have tightened the rope. We're staring at two conflicting realities, both backed by hard data, and no one can explain why the universe is telling two different stories. And just when you think you've wrapped your head around that, Webb reveals a possibility so bizarre it sounds like a sci-fi plot. What if the entire universe is inside a black hole? It sounds completely insane, like something ripped from a Christopher Nolan movie. But some scientists are now seriously entertaining the idea that our entire universe might be inside a black hole. This wild theory got a fresh jolt of attention after a strange and unexpected finding from the James Webb Space Telescope. As part of the JADE survey, researchers discovered that nearly two-thirds of distant galaxies appear to be rotating in the same direction, clockwise. That may not seem dramatic on the surface, but in a universe that's supposed to be random and isotropic, meaning it looks the same in all directions, this kind of pattern shouldn't exist. It's like flipping a coin 1,000 times and getting heads almost every time. The odds just don't make sense. One explanation being tossed around: we live inside a spinning black hole. According to this theory, the Big Bang wasn't actually the beginning of everything. It was the event horizon of a collapsing star in another universe. The rotation we're seeing in distant galaxies could be a remnant of that spin, still echoing through space-time. In other words, what we think is a universe might just be the interior of a larger cosmic structure hidden beyond anything we can observe. Now, to be clear, this isn't mainstream science yet, but the fact that reputable astrophysicists are even considering it tells you how bizarre the data is getting. Webb isn't just answering questions. It's ripping open the fabric of what we thought reality was. So if the universe really is inside a black hole, what's outside of it? And what else is the James Webb Telescope about to reveal? The James Webb Space Telescope didn't just give us prettier pictures of stars. It shattered our understanding of the universe. From galaxies forming far too early, to spiral structures that shouldn't exist, to dark matter behaving in ways we can't explain. Webb is forcing scientists to confront a reality that doesn't follow the rules we thought were unbreakable. It challenged our theories of galaxy formation. It deepened the mystery of dark matter. It pushed the Hubble tension into full-blown cosmic confusion. And it even raised the possibility that we're living inside something far stranger than we ever imagined, a spinning black hole with an entire unknown reality waiting just outside its edge. But the craziest part? This is just the beginning. Webb has only scratched the surface. With every new image, every data drop, we're being pulled deeper into a universe that's more complex, more alien, and more mind-bending than we were ever prepared for. So, if the rules of physics can be broken this easily, what else is the universe hiding? Stick around, because the next discovery might just rewrite reality again.